Welcome back to Dielectric Videos. On today's episode, I'm going to be practicing some brazing techniques for possible use in HVAC and other applications. Before I start this video, I want to mention that I am by no means an expert in brazing or any sort of pipe joining techniques. I am really just doing this for fun. I'm doing this because I have a project where I'm going to need to do some brazing and I'd like to see how hard it is. And really it's just sort of something to do, and I figured I'd film it to make a video. So don't take anything you're about to see in this video as expert advice. I'm not responsible for any injuries that improper technique that I may or may not display in this video may cause, and I'm also not responsible if these techniques are incorrect and cause damage to any of your equipment. I strongly and highly advise looking into other videos by actual trained professionals in this art and in this science before making any attempts of your own at brazing or doing any sort of high temperature work like this. So I have a couple pieces of copper pipe cut to length for basically testing. What I'm going to be doing is trying to braze some caps and threaded adapters onto these pipes so that I can then pressure test them with an air compressor. Now, I've never brazed before. This will be my very first attempt, and I may make some mistakes on this, so it's going to be a learning experience. So I'm going to basically start off with some steel wool. I'm going to clean the end of my line here, and I just want to scrape off that oxide layer that's on the outside. Now, for an HVAC application, you would definitely want to also remount the inside and make sure there's no steel wool remnants on the inside, but since we're just doing this for qualitative analysis and pressure testing, it's not necessary for us to, me to really clean up the inside of that. We do still need, of course, to take the oxide layer off for optimum wetting. You want to make sure that there's basically a clean, bare copper surface to allow the flux, or the braze rod rather, to wet as evenly as possible. Now I'm going to be using Stay-Sil 15, which is a phosphorus fluxed copper-silver alloy, 15% silver, and this material is basically designed for general purpose brazing. And I'm going to be using 1/2-inch copper tubing, as you can see here. So I'm going to take my copper cap and stick it on the pipe here, and the goal will be to make a gas-tight seal around this copper piece, around this joint here. So this will, like I said, be my first attempt. So what I'm going to try is just heating up the pipe and having a go at it. Now I'm going to be using MAP gas since this is a fairly small pipe, though it's typically recommended to use acetylene or even oxyacetylene if you have a larger diameter pipe or you want it to be a little bit faster process. But for now, for ease of access, I'm going to use MAP gas. So let's go ahead and start it. So what I'm doing now is I'm trying to evenly heat the pipe. I want to heat it till it starts to discolor, and maybe even till it starts to glow very slightly. But I don't want to get it too hot that it burns through. So now it's starting to discolor, so that means it's almost time to put the braze in. And you can kind of tap test to see if the braze is melting yet. So it's almost there. It's still got a little ways to go. But like I said, you don't want to get it so hot that the copper itself starts to burn and melt. It's starting to go. Alright, there we go, there we go. I'm going to get around the other side. And that top section looks good. I'm going to hit it from the bottom as well. That actually looks pretty good for a first attempt. So I'm going to let that cool down. Some people say it's okay to use a wet rag once it's done solidifying to cool the pipe off, but other people claim that doing that causes stress fractures and other weak points in the braze. So I'm going to let it cool down naturally, and I'll come back in a few minutes to put on the second piece, which will go on the other side. So the braze joint is all cooled down now, and it actually looks really good for the first attempt. I'm quite surprised with how easy that was. I think I went a little bit heavy-handed on the amount of braze material I put in. You can see there's a drip on the bottom here, but you can see it's pretty evenly distributed. I definitely didn't overheat the pipe because you can see there's no like burn spots or pinholes or anything. And the braze looks like it made it all the way around. I mean, that's pretty even. Not too much, like, no like dry spots for sure. So I'm going to go ahead and braze on the threaded fitting, and then we'll hook it up to some pressurized air and do a soapy water test. Alright, let's go ahead and do the other side next. So I think this one probably didn't go quite as well as the previous one, most notably because I noticed I think it took more heat to warm up the end of this, this fitting. Probably a larger amount of copper was there to heat up, more thermal mass. I also noticed that the braze seemed to not be wicking and not wetting on as well. It's possible there was a little more oxide on this side of the pipe than on the other one, or it could just have been, once again, that there was more thermal mass so it didn't get quite as hot. That being said, I'm pretty sure I got pretty even coverage all around, so I'm going to go ahead and let it cool off, scrape the oxide off, and then take a look to see how that goes. So this braze actually ended up turning out fairly well. Looks like fairly even coverage all around, a little bit of a drip once again on the lower side of it, but definitely once again not too much overheating of the pipe, and I don't see any significant gaps or voids in the braze so far. Now, here's a good opportunity to note why in an HVAC application you would want to flush the inside of the system with an inert gas like nitrogen to ensure that the oxidation that we scraped off the outside doesn't form on the inside. If you look down the inside of the pipe, you can sort of see, it may be hard to see in this light, let me see if I can get closer, you can see there's a lot of that black oxide inside this pipe. Now this is because we did this under atmosphere rather than under an inert gas environment, an atmosphere. And as a result, there's basically copper oxide deposits on the inside of the pipe, which, when introduced into an HVAC system, could potentially cause damage to the compressor or clog the filter dryer. That's why it's very important to make sure that if you're using this in an HVAC application, that you're flushing the system with an inert gas which will prevent oxidation during the braze. So I went ahead and attached an air line adapter to this with the valve, and I've charged this little copper slug to 120 psi of air. So what I'm going to do now is a soapy water test. So I've soaked this paper towel in water with soap mixed in, and I'm basically just going to drip a bunch of the soapy water onto the braze joints, and just for good measure I guess I'll put it on the Teflon tape joint as well. And I'm basically just going to watch to see if we see any bubbles forming. You'll see kind of a whitish foam anywhere that there's a failure point. And I don't see any bubbles anywhere on this. Certainly no bubbles accumulating. So that would lead me to believe that this braze is in fact airtight. And just for good measure, what we'll do is I'm going to leave this for a few hours with air in it, and I'll come back and see if it's held. Of course, that doesn't rule out if the valve is kind of leaky, but if it does hold pressure, then we'll know for sure that the brazes are solid. So now that I've done my first successful braze, I want to figure out if I can effectively do brazing with access to only one side of the pipe. This is likely to be the case in an application that I have coming up where I need to use the brazing techniques to actually join two pieces of pipe, where I'm going to have a very confined amount of space. I won't be able to get the torch on the other side, and I definitely won't be able to walk around it and apply rod from the other side. So I'm going to see how well this works just by basically running the blowtorch, the MAP gas torch, on one side of it, restricting myself to maybe 90 degrees of access, and I want to see if I can get the brazing filler or the brazing rod to wick all the way around under its own surface tension. So let's try it. Alright, I'm going to go around and inspect to see if the braze made it all the way around. And unfortunately it did not. So it may require that I actually end up moving the pipe or rotating the pipe in situ to make this work. Unless maybe I can come up with a clever way to wrap the braze rod around. So I might try applying a bend to the rod to see if maybe I can now get at it from the other side. So let's see if we can heat it up again. So that actually seemed to work pretty well. Let's take a look now from the other side. You can see it's glowing red hot. It's quite, almost probably too hot for the copper, but we'll take a look. Looks like the braze almost made it all the way around. There's still a little gap on the other side that's missing though. So maybe we can have one more go at it. That time it did make it all the way around, but it wasn't very clean. In fact, I'll move the camera around to show you what I can see from this other side. You can see here that the pipe is actually, it's got a big glob of material right there, and it is fully joined. It doesn't seem to have any porosity, but it's not a super high quality joint either. So this indicates that although it seems to be fairly trivial to do standard brazing from when you have access to all edges of the pipe, brazing in confined spaces is much more challenging and potentially could lead to a reduced reliability of the joint. So we're going to have to take particularly special care when brazing in a confined space. A technique that I just thought of is I want to try applying the braze rod to the other side first. That way I can directly observe if the material is wicking all the way around. This should give me a better indication as to the quality of the joint that's being formed. So I'm going to try it with this threaded end piece here. How about that? I'm going to go have a look once this gets a little bit cooler, and let's see how it looks on all sides. So obviously you can see that the braze made it on this side, but let's go take a look on the other side and see what it looks like. Looks like it made it most of the way around. Let me zoom in there so you can see up close. I guess that's as far in as we can get. Yeah, no, it definitely made it all the way around with only that 90-degree angle of torch application and limited window of rod implementation. One interesting unforeseen consequence of the brazing at high temperature around the threaded fitting is it seems to have annealed the copper on the threads, to the point that it will no longer hold a good seal, and it will actually strip the copper if you tighten it down too much. Now, because of this, you want to be particularly careful when you're brazing not to adversely affect any threaded fittings. That being said, though, if you're just going to be working on line-to-line with no threads in between, with just copper tubing, the annealing shouldn't be a problem unless you're dealing with an exceptionally high-pressure application, in which case brazing is probably not necessarily going to be the best joinery technique. So what I'm going to do now is proceed to the soapy water testing to show that even though this joint doesn't hold pressure, and I've had to hook it up to an air line to maintain pressure, we should still be able to get these brazes to hold pressure. So let's take a look at that next. So with the air hose connected, we can perform a soapy water test. First, I'll show you what the failed soapy water test looks like. See all those bubbles forming? That indicates a very bad leak, and this would never hold refrigerant in an HVAC application. It would leak out within hours. I'll wipe that soapy water off of it now, and we'll try that same experiment with the brazes. So let's just put some water on each braze and focus it here. And as I turn it, you can see there are no suds or bubbles of any kind forming on either of these brazes. Definitely a successful operation there. So now that I've tested a few things, I'm going to do one more practice run with a confined access, a confined angle of access to the joint, and I'm going to try that on both sides of this pipe. So the whole point here is basically to see if the techniques that I developed with the reach around method for limited access are going to be viable, and if I can make them make these connections repeatably. Now I'm not going to pressure test this one, I'm going to just visually inspect it. But I do want to see if I can make these connections work effectively without needing to do any further... I don't want to have to reheat the pipe more than once, basically. I'd like to see if I can do both sides in one fell swoop. So I'm going to get my same piece of brazing rod, and I'm going to go ahead and bend it into something of an arc. And that's going to allow me to basically approach the line from the back side first. And I'm going to now try and heat the line up. So let's go ahead and start that process. Now I'm kind of moving the flame around because I don't want to create a super high hot spot on the pipe. I do want to transfer as much heat as possible into it as I can, but I don't want to have one spot get so hot that it starts to burn through. You can see it's barely starting to glow red. That's what I want to see. That means it's going to be about ready. A little bit too hot there maybe, but that's probably okay. There we go. Now it's melting, so I'm going around the back. Now I got it in the front, and I'm going to finish it off here. See how that does when it cools off. So this one seems to have turned out really quite nicely. You can see if I go around, there's a pretty continuous layer of braze material all the way around the pipe. Continuous, no major gaps, no major jumps. This looks pretty much like a professional job here. Obviously probably not as good as it can be done, but definitely not bad in terms of the coverage of the braze material. So let's go ahead and put the other side on with the threaded adapter fitting. I hope you enjoyed my video on experimenting with brazing using silver Stay-Sil 15 alloy and MAP gas torch. I want to reiterate that anything you see in this video is to be done at your own risk, and I am not by any means an expert. This was my very first time. I've not been formally trained or apprenticed or anything like that in brazing. I just wanted to get out and mess around with a torch. So keep in mind there are hazards involved. You can be burned, the open flame can present a fire hazard, and if you do this in an indoor or confined space, there's a risk of asphyxiation or carbon monoxide poisoning. So ensure that you have adequate ventilation and that you use the necessary precautions to ensure that you aren't injured or don't cause any property damage while working on whatever you're using this brazing technique to do. And like I said, I'm not an expert, so I'm not responsible if you destroy your air conditioner or whatever else you might be brazing due to a faulty braze joint. I also wanted to mention, like I said, you want to use an inert gas if this is going to be used on any sort of a closed-loop system or anywhere that contaminants from the oxides that can form inside the pipe would be an issue. So hopefully you enjoyed this video, hopefully you learned something, and I'm glad you're watching this channel. So I will see you in the next video. Thanks for watching.